Okay, this is a video to help you get started on the circumference Google Slides. Okay, especially if you're quarantined, but if you just want to go back and look at this if you're in class. Okay, let's, on this first slide, let's click this link because I want to help you know what's going on before we look at formulas. Okay, we're looking at circumference. Okay, circumference is the distance around a circle. Okay, and I'm going to let the class kind of play with this GeoGebra lesson, and I'll show you what we're doing. If you take this point, that little point, and you drag it up and down, see how you get a different diameter? See, the diameter is the distance through the middle of the circle. The diameter is 2. We could make it different diameters. I can go up to a diameter of 2.7. Okay, I can make it whatever I want. 3.2, 3.3, 3.6. I guess you have to stop at 3.6, but the idea is you can get various diameters, okay, just by moving this. And then I want you to see what the circumference is, the distance around based on that diameter. And the way you can do that, see the big circle? I'm going to put this back on too. Okay, see this big circle? If I drag it, see, it's showing me the distance around that circle. At least it's stretching out the distance around that circle. See right there? So when I had a diameter of 2, my circumference is about 6.3. So play with some different diameters. Drag it back. Maybe do a diameter of 2.5, whatever, it doesn't matter. Okay, take the big circle and move it. So a diameter of 2.5 gives me a circumference of about 7.9. But this is the really cool part that I want you to see. If you click this, I shouldn't say click, move it. Look what's happening. Look what this is showing you. Okay, when I had a diameter of 2.5, it's showing you how many diameters make up that circumference. Okay, look at this. And I wanted the class to play with this on their own for a while, but watch. The circumference would be 1 diameter, okay, a second diameter, a third diameter, but it's a little short. So it's a little bit, the circumference is a little bit more than 3 diameters. Just a little bit more than 3 of them. Okay? And what I also wanted the class to think about, okay, is this diameter, let's go back and look at it this way for a minute. This diameter could be thought of as 2 radiuses. You know, there's no plural for radius. I mean, you don't say radiuses, okay? But you could think of this diameter as 2 radii, one here and one here. So if you know what 2 radii are in a circle, then you know those 2 radii would be multiplied by about 3. Same idea, about 3. So the circumference of a circle is about 3 times bigger than the diameter. Or the circumference is about 3 times bigger than 2 radiuses, 2 radii. Okay, let's get out of there for a minute. Okay, so here's the questions I want you to think about how how many diameters make up the circumference. Okay, about 3. A little bit more, but about 3. And about how many 2 radii, 2 radii together make up the circumference. It's really the same question, about 3. Okay, let's look at the same information, but let's look at more accurate data. Okay, let's say that I used that website or a different way to find the circumference given diameter, but I rounded to the 100th. I got an answer to the 100th. So a diameter of 1 gives me a 3.14 circumference. A diameter of 2 gives me a 6.28. Okay, 3, 9.42. Okay, and so on. Okay, so here's a data table showing me various diameters along with the circumferences. Okay, here's a graph showing exactly the same information. See, here's 0, 0. Here's 1, 3.14. Here's 2, 6.28. Okay, I just had a question for you. Is this relationship between the diameter and the circumference proportional? Okay, please give a reason for both the table and the graph. Okay, think about it. If you're quarantining, think about this before you just type this in and listen to me. Okay, this is proportional because the data table, if you took 3.14 divided by 1, you get 3.14. If you take 6.28 divided by 2, you get 3.14. Okay, if you take 9.42 divided by 3, you get 3.14. Okay, and for the other two as well. So yes. How can I go back? Okay, proportional. I'm going to put proportional table because every, okay, I'm going to use y divided by x instead of c divided by d because you're used to that. Because every y divided by x gives me the same answer, 3.14. Okay. The graph is proportional. Today, the graph is proportional, okay, because it's a straight line. You remember, for a graph, it's got to be a straight line, and it is. That goes through the origin 0, 0. Okay, so that is a proportional graph. The graph is proportional because it is a straight line that passes through the origin. Be familiar with that word, origin. Okay, so this is a proportional relationship. Diameter and circumference is a form of proportional relationship because every y value divided by x value in the data table gives you the same answer every time. And the graph is a line that goes through the origin 0, 0. Okay, I better stop there. I'll have some more information on other videos and images.